2. Interior of the Earth. Sources of information about the interior. The Earth's radius is 6,370 kilometers. No one can reach the center of the Earth and make observations or collect samples of the material. Under such conditions, you may wonder how scientists tell us about the Earth's interior and the type of materials that exist at such depths. Most of our knowledge about the interior of the Earth is largely based on estimates and inferences. Direct sources of Earth interior. Gold mines in South Africa are as deep as 3 to 4 kilometers. Going beyond this depth is not possible as it is very hot at this depth. Scientists world over are working on two major projects such as Deep Ocean Drilling Project and Integrated Ocean Drilling Project. The deepest drill at Kola, in Arctic Ocean, has so far reached a depth of 12 kilometers. This and many deep drilling projects have provided large volume of information through the analysis of materials collected at different depths. Volcanic eruption forms another source of obtaining direct information. As and when the molten material, magma, is thrown onto the surface of the Earth, during volcanic eruption it becomes available for laboratory analysis. Indirect sources of interior of Earth. Analysis of properties of matter indirectly provides information about the interior. It is also known that the density of the material also increases with depth. Knowing the total thickness of the Earth, scientists have estimated the values of temperature, pressure and the density of materials at different depths. The meteors reaching Earth contains the material and the structure similar to Earth. Hence, this becomes yet another source of information about the interior of the Earth. The other indirect sources include gravitation, magnetic field, and seismic activity. Earthquake. The study of seismic waves provides a complete picture of the layered interior. An earthquake in simple words is shaking of the Earth. It is a natural event. It is caused due to release of energy, which generates waves that travel in all directions. Why does the Earth shake? The release of energy occurs along a fault. A fault is a sharp break in the crustal rocks. Rocks along a fault tend to move in opposite directions. As the overlying rock strata press them, the friction locks them together. However, their tendency to move apart at some point of time overcomes the friction. As a result, the blocks get deformed and eventually, they slide past one another abruptly. This causes a release of energy, and the energy waves travel in all directions. The point where the energy is released is called the focus of an earthquake. Alternatively, it is called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface, nearest to the focus, is called epicenter. It is the first one to experience the waves. It is a point directly above the focus. Earthquake waves. All natural earthquakes take place in the lithosphere. Lithosphere is about 200 kilometers from surface of Earth. An instrument called seismograph records the waves reaching the surface. A curve of earthquake waves recorded on the seismograph. The curve shows three distinct sections, each representing different types of wave patterns. Types of earthquake waves. Body waves. Body waves are generated due to the release of energy at the focus and move in all directions traveling through the body of the Earth. Hence, the name body waves. Surface waves. The body waves interact with the surface rocks and generate new set of waves called surface waves. These waves move along the surface. The velocity of waves changes as they travel through materials with different densities. The denser the material, the higher is the velocity. Their direction also changes as they reflect or refract when coming across materials with different densities. There are two types of body waves called P and S waves. P waves move faster and are the first to arrive at the surface. These are also called primary waves. The P waves are similar to sound waves. They travel through gaseous, liquid and solid materials. S waves arrive at the surface with some time lag. These are called secondary waves. An important fact about S waves is that they can travel only through solid materials. This characteristic of the S waves is quite important. It has helped scientists to understand the structure of the interior of the Earth. Reflection causes waves to rebound, whereas refraction makes waves move in different directions. The variations in the direction of waves are inferred with the help of their record on seismograph. The surface waves are the last to report on seismograph. These waves are more destructive. They cause displacement of rocks, and hence, the collapse of structures occurs. Propagation of earthquake waves. Different types of earthquake waves travel in different manners. As they move or propagate, they cause vibration in the body of the rocks through which they pass. P waves vibrate parallel to the direction of the wave. This exerts pressure on the material in the direction of the propagation. As a result, it creates density differences in the material, leading to stretching and squeezing of the material. Other three waves vibrate perpendicular to the direction of propagation. The direction of vibrations of S waves is perpendicular to the wave direction in the vertical plane. Hence, they create troughs and crests in the material through which they pass. Surface waves are considered to be the most damaging waves. Emergence of shadow zone. Earthquake waves get recorded in seismographs located at far-off locations. However, there exist some specific areas where the waves are not reported. Such a zone is called the shadow zone. The study of different events reveals that for each earthquake, there exists an altogether different shadow zone. It was observed that seismographs located at any distance within 105 degrees from the epicenter recorded the arrival of both P and S waves. However, the seismographs located beyond 145 degrees from epicenter record the arrival of P waves, but not that of S waves. Thus, a zone between 105 degrees and 145 degrees from epicenter was identified as the shadow zone for both the types of waves. The entire zone beyond 105 degrees does not receive S waves. The shadow zone of S wave is much larger than that of the P waves. The shadow zone of P waves appears as a band around the Earth between 105 degrees and 145 degrees away from the epicenter. The shadow zone of S waves is not only larger in extent, but it is also a little over 40% of the Earth's surface. You can draw the shadow zone for any earthquake provided you know the location of the epicenter. Types of earthquakes. The most common ones are the tectonic earthquakes. These are generated due to sliding of rocks along a fault plane. A special class of tectonic earthquake is sometimes recognized as volcanic earthquake. However, These are confined to areas of active volcanoes. In the areas of intense mining activity, sometimes the roofs of underground mines collapse, causing minor tremors. These are called collapse earthquakes. Ground shaking may also occur due to the explosion of chemical or nuclear devices. Such tremors are called explosion earthquakes. The earthquakes that occur in the areas of large reservoirs are referred to as reservoir-induced earthquakes. Measuring earthquakes. The earthquake events are scaled either according to the magnitude or intensity of the shock. The magnitude scale is known as the Richter scale. The magnitude relates to the energy released during the quake. The magnitude is expressed in absolute numbers, 0 to 10. The intensity scale is named after Macaulay, an Italian seismologist. The intensity scale takes into account the visible damage caused by the event. The range of intensity scale is from 1 to 12. Effects of earthquake. Ground shaking, differential ground settlement, land and mudslides, soil liquefaction, ground lurching, avalanches, ground displacement, floods from dam and levee failures, fires, structural collapse, falling objects, tsunami. Structure of the earth. The crust. It is the outermost solid part of the earth. It is brittle in nature. The thickness of the crust varies under the oceanic and continental areas. Oceanic crust is thinner as compared to the continental crust. The mean thickness of oceanic crust is 5 kilometers, whereas that of the continental is around 30 kilometers. The continental crust is thicker in the areas of major mountain systems. It is as much as 70 kilometers thick in the Himalayan region. It is made up of heavier rocks having density of 3 grams/cm3. This type of rock found in the oceanic crust is basalt. The mean density of material in oceanic crust is 2.7 grams/cm3. The mantle. The portion of the interior beyond the crust is called the mantle. The mantle extends from Mohu's discontinuity to a depth of 2,900 kilometers. The upper portion of the mantle is called asthenosphere. The word astheno means weak. It is considered to be extending up to 400 kilometers. It is the main source of magma that finds its way to the surface during volcanic eruptions. It has a density higher than the crust's, 3.4 grams/cm3. The crust and the uppermost part of the mantle are called lithosphere. Its thickness ranges from 10 to 200 kilometers. The lower mantle extends beyond the asthenosphere. It is in solid state. The core. As indicated earlier, the earthquake wave velocities helped in understanding the existence of the core of the Earth. The core mantle boundary is located at the depth of 2,900 kilometers. The outer core is in liquid state while the inner core is in solid state. The density of material at the mantle core boundary is around 5 grams per centimeter cube, and at the center of the Earth at 6,300 kilometers, the density value is around 13 grams per centimeter cube. The core is forms. A volcano is a place where gases, ashes and/or molten rock material lava escape to the ground. A volcano is called an active volcano if the materials mentioned are being released or have been released out in the recent past. The layer below the solid crust is mantle. It has higher density than that of the crust. The mantle contains a weaker zone called asthenosphere. It is from this that the molten rock materials find their way to the surface. The material in the upper mantle portion is called magma. Once it starts moving towards the crust or it reaches the surface, it is referred to as lava. The material that reaches the ground includes lava flows, pyroclastic debris, volcanic bombs, ash and dust, and gases such as nitrogen compounds, sulfur compounds, and minor amounts of chlorine, hydrogen, and argon. Types of volcanoes. Shield volcanoes. Barring the basalt flows, the shield volcanoes are the largest of all the volcanoes on the Earth. The Hawaiian volcanoes are the most famous examples. These volcanoes are mostly made up of basalt, a type of lava that is very fluid when erupted. For this reason, these volcanoes are not steep. They become explosive if somehow water gets into the vent, otherwise, they are characterized by low explosivity. The upcoming lava moves in the form of a fountain and throws out the cone at the top of the vent and develops into cinder cone. Composite volcanoes. These volcanoes are characterized by eruptions of cooler and more viscous lavas than basalt. These volcanoes often result in explosive eruptions. Along with lava, large quantities of pyroclastic material and ashes find their way to the ground. This material accumulates in the vicinity of the vent openings, leading to formation of layers, and this makes the mounts appear as composite volcanoes. Caldera. These are the most explosive of the Earth's volcanoes. They are usually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. The collapsed depressions are called calderas. Their explosiveness indicates that the magma chamber supplying the lava is not only huge but is also in close vicinity. Flood basalt provinces. These volcanoes outpour highly fluid lava that flows for long distances. Some parts of the world are covered by thousands of square kilometers of thick basalt lava flows. There can be a series of flows, with some flows attaining thickness of more than 50 meters. Individual flows may extend for hundreds of km. The Deccan Traps from India, presently covering most of the Maharashtra plateau, are a much larger flood basalt province. It is believed that initially the trap formations covered a much larger area than the present. Mid-ocean ridge volcanoes. These volcanoes occur in the oceanic areas. There is a system of mid-ocean ridges more than 70,000 kilometers long that stretches through all the ocean basins. The central portion of this ridge experiences frequent eruptions. Volcanic landforms. Intrusive forms. The lava that is released during volcanic eruptions on cooling develops into igneous rocks. The cooling may take place either on reaching the surface or also while the lava is still in the crustal portion. Depending on the location of the cooling of the lava, igneous rocks are classified as volcanic rocks, cooling at the surface, and plutonic rocks, cooling in the crust. The lava that cools within the crustal portions assumes different forms. These forms are called intrusive forms. Batholiths. A large body of magmatic material that cools in the deeper depth of the crust develops in the form of large domes. They appear on the surface only after the denudational processes remove the overlying materials. They cover large areas, and at times, assume depth that may be several km. These are granitic bodies. Batholiths are the cooled portion of magma chambers. Leucoliths. These are large dome-shaped, intrusive bodies with a level base and connected by a pipe-like conduit from below. It resembles the surface volcanic domes of composite volcano, only these are located at deeper depths. It can be regarded as the localized source of lava that finds its way to the surface. The Karnataka Plateau is spotted with domal hails of granite rocks. Most of these, now exfoliated, are examples of leucoliths or batholiths. Lipolith. As and when the lava moves upwards, a portion of the same may tend to move in a horizontal direction wherever it finds a weak plane. It may get rested in different forms. In case it develops into a saucer shape, concave to the sky body, it is called lipolith. Phacolith. A wavy mass of intrusive rocks, at times, is found at the base of synclines or at the top of anticline in folded igneous country. Such wavy materials have a definite conduit to source beneath in the form of magma chambers, subsequently developed as batholiths. These are called the phacoliths. Sills. The near horizontal bodies of the intrusive igneous rocks are called sill or sheet, depending on the thickness of the material. The thinner ones are called sheets while the thick horizontal deposits are called sills. Dikes. When the lava makes its way through cracks and the fissures developed in the land, it solidifies almost perpendicular to the ground. It gets cooled in the same position to develop a wall-like structure. Such structures are called dikes. These are the most commonly found intrusive forms in the western Maharashtra area.